Hello and welcome back to the Operations Research 2 course. And this is our second week talking about dynamic programming. This week we are going to look at some cases that we may solve using dynamic programming. Let's start with the inventory problem. Let's start with some illustration. Let's say at the beginning of the period we have one item in our warehouse. And then we produce two items at this period, and then the demand of this period equals 2. So at the end of the period, we will have one item in our warehouse. And let's say we also start with one item at the beginning of the period, but in this example, let's say we produce 5 items. The demand is 3, and then so at the end of this period, we end up with one item from the beginning of the period, plus 5 that we produce, minus 3 that we sent out for the demand. So 1 plus 5 equals 6 minus 3. So we'll end up with 3 items in the inventory. Another example, if we have 4 items and then we produce nothing, but the demand equals 4, it means that at the end of this period, we are left with 0 inventory because we start with 4, the demand is 4, and we produce nothing. So at the end, we end up with 0 items. So here are the characteristics of the inventory problem in this section. At the beginning of period 1, the demand for each period is known for sure. So at the beginning of the problem, we already know what are the demands for each of the next periods. And then what we need to do is that we need to decide or determine how many units should be produced at each period. Third characteristic is that the demand must be met on time, either from inventory or from current production. And then we have limited storage capacity. And finally, the goal is to minimize the total cost of meeting the demands on time for all periods. So here's the problem. We know at the beginning the demand for the product during each of the next 4 months as follows. Month 1, 1 unit, month 2, 3 units, month 3, 2 units, and finally month 4, 4 units. And we are going to break this problem into months, so month becomes the stage. Why is this the case? If you think about it, a problem with 1 month planning is simpler than 2 months, 2 months is simpler than 3 months, 3 months is simpler than 4. So we are going to break this problem into months because 1 month problem is simpler to solve than 2 months, 3 months, or 4 month problem. Okay, and then what we need to decide each month is that we need to determine how many units should be produced during the current month. And then we have various costs. So the first one is setup cost, $3. This is a fixed cost. So if you produce, let's say 1 unit, 2 units, 3 units, and so on, we have the setup cost of $3, and this is fixed. As long as you produce something, you pay $3. And then variable cost depends on how many units you produce because it says $1 for every unit. Okay. We have also a holding cost, 50 cents per unit that we store at the end of each month. And then next we have the maximum capacity production. So at each month we can produce at most 5 units. And then finally at the end of each month the restriction for ending inventory is 4 units. So our warehouse can only store at most 4 units. So what we want to do is we would like to minimize the sum of production costs and holding costs during the next 4 months. So this will be something that we formulate in our recursion function. So we already have the stage, decision, and recurrent function. Now the only thing that we have not seen explicitly in this problem description is that the state. But when we talk about how we are going to solve this problem, I will show you how we may find the state. Okay, so from the problem, we already see explicitly the stage, the decision, and what we need to do in our in our recursion function, which is to minimize the sum of production and holding cost. Now you may pause the video and read the problem carefully. So let's start with month 4. We are going to solve this problem backward, means that we are going to start with month 4, 3, 2, until finally we reach month 1. Okay, so the first question I'd like to ask you is that what are the possible number of inventory at the beginning of month 4? So how many items are possible that we see in our inventory at the beginning of month 4? So if we go back to the problem, we see that there is a restriction saying that at the end of any month, we can store at most 4 units. It means that at the beginning of month 4, the possible number of inventory that we see is between 0 to 4, including 0, including 4. Because it is possible that we see 4 items at the beginning of month 4 because that is the maximum capacity of the warehouse. So maybe we see 4 items. Or at the other extreme, maybe we see no items at the beginning of month 4, right? Because somehow we just don't store any item at the end of month 3. Okay, so remember that we don't know yet which number is the actual number or the optimal number because we're still talking about possible number. So the possible number of inventory at the beginning of month 4 is 0, 1, 2, 3, 4. Now we know the demand of month 4 is 4 units and we must satisfy that demand. So the next question is that what are the reasonable decisions with respect to each inventory level? Remember, in this problem, we need to decide how many items we're going to produce at each month. Well, if you think about it, let's say if your inventory is 4 and the demand is 4, then the only reasonable decision is that producing 4 units. Right? Because why would you want to produce more units? Especially because month 4 is the last in your planning period. So it's only reasonable that if you have the beginning inventory of 4, then you produce 0. On the other extreme, if your beginning inventory equals 0, then the only reasonable decision is producing 4 units. Okay, because why is this the case? Because the demand is 4 units and you need to satisfy the demand. And in between, let's say you have 3 units as the beginning inventory, then the reasonable decision is that you produce 1 item. Because the demand is 4, you can satisfy it using 3 units from the beginning inventory plus 1 that you produce. So the beginning inventory is the state of this problem. And then corresponding to the state, we have the decision, how many items we produce. So we have seen the stage, which is the month. We have seen the state, which is the beginning inventory of that month. And then we have also seen the decision correspond to each state. Now let's compute the cost of each of these states and decision. So let's say the state is 0, so we begin this month with 0 inventory. The decision is producing 4 units because the demand is 4 and our beginning inventory is 0. So we need to produce 4 units. The cost of producing 4 units equals $7 because 3 from the fixed cost and 4 is the variable cost. So the total cost of producing 4 units is $7. And then here it says the best decision at stage 4, if we start stage 4 with 0 items, is producing 4 units. So F has the units of dollars because it's talking about the cost, and X has the unit of units. It's the decision, how many you produce. Okay, another example, if we have F for 4, means that at the beginning of month 4, we have 4 units in the inventory. Because the demand is 4, we don't need to produce anything. So the total cost equals 0, and the decision is also 0. So X44 means the decision at stage 4. If we begin this period with 4 units in the inventory, equals 0 means that we are going to produce 0. So this is our recursion function. We are going to find the minimum cost at each stage corresponding to the state and the possible decisions. Now let's go to stage 3. I'm going to ask the same questions. What are the possible number of inventory at the beginning of month 3? The answer is the same. It is between 0 and 4, including 0, including 4. Which means that at the beginning of month 3, we may see that our warehouse is empty. There is 0 inventory left from the previous month. On the other extreme, we may see that our warehouse is full. There are 4 items in the warehouse. And then anything in between them is also possible. So because all of these numbers, they're all possible, we start by saying that if the inventory at the beginning of month 3 equals 0. So next, we are going to say if we have 1 inventory, if we have 2 inventory, if we have 3, and then if we have 4. But now let's start with if we have 0 inventory. So here, 0 inventory is our state. So the beginning inventory is 0 and it becomes our state. And then we have 4 possible decisions, which is producing 2 units, producing 3 units, producing 4 units, up to producing 5 units. Why are these numbers are the possible decisions? Well, if you go back to the problem, you see that the demand for month 3 equals 2 units. So if you have 0 inventory, at least you need to produce 2 units to meet the demands, right? You do not have anything at the beginning of the month, 0 inventory. The demand is 2, you must satisfy the demand. So at least you need to produce 2 items to meet the demand. At most, you can produce 5 items because remember the capacity, the production capacity equals 5 units. So in this case, you cannot produce more than 5 units because your production capacity is limited to 5 only. So that's why you see there are 4 rows here, 0, 0, 0, 0, because we have 4 possible decisions, producing 2 units, 3 units, 4 units, and 5 units. Now that we have seen all the possible decisions corresponding to the state 0, let's compute the cost. So the cost consists of inventory cost and the production cost. For example, if we start with 0 inventory, we produce 2 units, and the demand for month 3 is also 2 units. The inventory that we have equals I is the beginning inventory 0 plus 2 units minus 2 equals 0 times the inventory cost equals 50 cents or $0.5. So 0.5 times 0 equals 0. The production cost of 2 units equals 5 because there is a fixed cost of $3 plus variable cost $2. 3 plus 2 equals 5. So the cost for this decision at this stage equals 5. And then let's see another example before we move on to the next column. Let's say the last one. We start with 0 inventory. We produce 5 items. So the ending inventory equals 0 plus 5 minus the demand 2. So we have 3 units in the inventory. Because the holding cost equals 50 cents, so the inventory becomes 3 times half equals 3 over 2. And then the production cost equals the fixed cost $3 plus variable cost $5 because we produce 5 units, so equals 8. So the total cost at this stage for this decision equals 19 over 2. And you may try to calculate the other cost for this decision producing 3 units and this decision producing 4 units. Now remember that because this is only the cost for stage 3, we need to take into account the cost from stage 4. So this is the cost from stage 4, and the state here is the beginning inventory of stage 4, or in other words, the ending inventory for stage 3. So what is the ending inventory of stage 3? It is equals I, beginning inventory of stage 3, plus X, how many we produce at this period, minus 2, the demand of this period. So F4, and then in the bracket I plus X minus 2, it is the cost of the stage 4 when the beginning inventory of stage 4 equals I plus X minus 2. So if you go back to the calculation of stage 4, you will see that this 7 here is F40. 6 here is F41. This is F42. And this is F43. So now that we have cost for this stage, month 3, we have the cost for the later stages, month 4 and so on. We may compute the total cost for month 3 and 4 corresponding to the state 3. So here are the costs, and then because these are all the possible decisions, the cost from producing 2, 3, 4, and 5, we pick the one that is smallest. So here the final column says that the best cost is 12, the best decision is 2, if the stage is 3, and the state is 0. So this 12 is $12, this 2 is 2 units. Okay, so that was the calculation when we say if we have 0 inventory at the beginning of month 3. Let's see another possibility. If the inventory at the beginning of month 3 equals 4. So now I'm going to look at the other extreme. So here 4 becomes the state, and then the possible decisions are 0, 1, and 2. Why is this the case? Again, if we have 4 units at the beginning of month 3, the demand at month 3 only 2 units, so it is possible that we produce nothing. We just use our beginning inventory to satisfy the demand. We may produce 1, we may produce 2, because if we produce 2, then we will have 4 units from the beginning inventory, 2 units from the production, minus 2 from the demand. We will have 4 units as the ending inventory. Remember that 4 units as the inventory is the maximum that our warehouse can hold. That's why in this column you only see 0, 1, 2. We don't go to 3, 4, and 5 because 2 is the maximum number that we may produce, such that we do not violate the restriction in our warehouse. Okay, so because we have 3 possible decisions, you can actually think of this tree as something that we write with a curly brackets. Means that we are going to choose among these 3 possibilities which one is the best. In other words, which possibility gives us the minimum cost. And then same as before, we are going to calculate the cost for each of these decisions. And then we are going to also take a look at the cost from the later stages. So this 5 comes from F4. So use this formula I plus X minus 2. So that will be F4, 4 plus 0 minus 2. So this is F4, 2. This is F4, so 4 plus 1 minus 2, 5 minus 2. This is F4, 3. And this is F4, 4. Okay, and then we will have the total cost for months 3 and 4. And same as before, we pick the one that is smallest, such that we can say if at stage 3 our beginning inventory equals 4 units, then the best cost is $6. The best decision is producing 0 units. Now do the same thing with the state 1. So if we have 1 unit as the beginning inventory of month 3, then do the same thing if we have 2 items as the beginning inventory of month 3, and then if we have 3 items as the beginning inventory at month 3. Please be careful at determining the possible decisions corresponding to each month. And then you need to complete all of this such that you know the best decision and best cost for each state at month 3 or at stage 3. Now I strongly suggest you to pause the video and really take the time to calculate, let's say, all the numbers correspond to state 1 until you get the conclusion at the last column. Now let's move backward again to stage 2, which means that now we are at month 2. Same question, what are the possible number of inventory at the beginning of month 2? And then same answer, 0 to 4, including 0, including 4. So same as before, we are going to look at all the possibilities here. If the beginning inventory of month 2 equals 0. So the state is 0, and then the possible decisions are 3, 4, and 5. Why we start at 3? Because at month 2, the demand is 3 units. If you have nothing as the beginning inventory, of course, at least you need to produce 3 units. At most, you can produce 5 units because 5 is the maximum production capacity. And then you calculate the cost at this month. Remember, the inventory cost is half times your ending inventory of this month, plus this is the fixed cost and the variable cost. So if you produce 5, means that your ending inventory will be um, 0 plus 5 minus 3, so your ending inventory is 2 units. 2 times half, because the cost of keeping inventory is half a dollar. So 0.5 times 2 units equals 1. And then fixed cost $3, variable cost $5 equals 8. So the cost for this stage is $9 if you produce 5 items. And then do not forget to um, add the cost from the later stages. So you need to add F3 something. So this $12 is F3 I plus X minus 3. I equals 0 plus X equals 3. 0 plus 3 minus 3. This is F3 0. And so this is F3 1. This is F3 2. This is F3 2 because I plus X minus 3. 0 plus 5 minus 3 equals 2. So yes, this is F3 2. And then you take the sum between the cost from this stage and the later stage such that you may get the conclusion. The best cost is $16. The best decision is producing 5 units if at stage 2 you begin with 0 inventory. Same as before, I would like you to pause the video and then try at least one of this state. Let's say you try state equals 3 and then go over the table such that you get this final conclusion, and then you may interpret that conclusion. If you cannot do this, if there's a confusion, please talk to me, okay? We go backward again, and now we are at stage 1. Same as before, I asked this question: what are the possible number of inventory at the beginning of month 1? However, this time the answer is different. The answer is 0 and only 0. We know this for sure because based on the problem description, if you go back to the problem, you see that it says at the beginning of month 1, we have 0 items in the inventory. So in this case, we only have one state here. So the only possible state is 0. That's why I don't write if or anything here, because the only possible state for stage 1 is 0. However, we still have many possible decisions from 1 to 5. Same as before, you calculate the cost for this stage. Do not forget to add the cost from the later stages, which means F2 something. And then based on the total cost, we have this many possible decisions. We pick the one that gives us the minimum cost. So this is the best cost, $20. The best decision is producing 1 unit at stage 1. And then we begin this stage with the state 0 inventory. So I just like to point out that this table may also be written in an equation, and it is called the recursion function or equation that looks like this. So F1I means that we are at stage 1 at this moment, and our beginning inventory is I, and then we are going to look at all possible decisions. So the small x here, we're going to look at all the possible decisions and pick the one that gives us the minimum cost. How can we compute the cost? Well, it consists of the inventory cost, production cost, and the cost from the later stages. The later stages is denoted by F2 because we are going to take the sum with F2, the cost from stage 2. And then here the state changes from I to become I plus X minus 1. I is our beginning inventory, plus X is how many we produce, minus 1 is the demand in month 1. In other words, this is the ending inventory of month 1 or the beginning inventory of month 2. Now let's see how we may read the optimal solution from all the calculations that we have done. So start at stage 1. The beginning inventory equals 0. And then the best decision is producing 1 units. Okay, because the demand is 1, the ending inventory equals 0. Begin with 0, produce 1, and then the demand is 1, so the ending inventory equals 0 again. Or in other words, this 0 units here becomes the beginning inventory for stage 2. Then you go to stage 2 and look in particular for state 0. So the beginning inventory is 0 because from the previous slide we know that the ending inventory of month 1 equals 0. So we begin month 2 with 0 as well. The best decision is producing 5 units. The demand for month 2 equals 3, so ending inventory is 0 plus 5 minus 3 equals 2 units. And this 2 units becomes the beginning inventory for stage 3. So you go to stage 3 and then look at the beginning inventory of 2 units. The best decision is producing 0 units here. It's producing 0 units. The demand is 2 for month 3, so the ending inventory of this month equals 0. And so 0 becomes the beginning inventory for stage 4. You go to stage 4 and look at the one with the state 0, which means the beginning inventory is 0, and the only possible decision for this is producing 4 units because the demand for month 4 equals 4, so we'll end up with 0 inventory. So that was our optimal production schedule. And if we do the schedule, then we obtain the optimal cost equals $20, as you can see it here. Okay, so that's the end of how we may use dynamic programming to solve the inventory problem. In the next video, we are going to use dynamic programming to solve another type of problem. So see you on the next one. Thank you.